So we know the project title is a mouthful. Analysis of diabetes mellitus for early prediction using optimal feature selection. What does that even mean? It simply means we will create an early prediction system for diabetes using machine learning algorithms to output the possibility of a person being diabetic or not. The key part of this project is that we are making use of optimal feature selection. More on that in a bit. But why this project? 10% of the adult population suffers from diabetes. According to WHO, in 2016, 3% of the total deaths in all age groups resulted from diabetes. There is no strategy, policy, or action plan available to reduce overweight, obesity, and physical inactivity in Pakistan. There is a major lack in the availability of medicines, basic technologies, and procedures in the public health sector. There is no quick way to tell if a person is diabetic. So, solution for it? Presenting you Pakistan's first pre-diabetic prediction system. It has been trained on a real data set. More on that in a bit. It makes use of optimal feature selection technique. It has been tested using naive Bayes, support vector machine, and random forest machine learning algorithms. The predictor system has a wonderful accuracy of 87%. So there are diabetes early prediction systems in America and even Canada, but there is none in Pakistan. We'd be the first to create a prediction system which will output the possibility and the risk level of a person being diabetic or not. Our aim for this project is to create an early prediction system that will create awareness among people about their sugar intake. The objectives are as follows on your screen. We'll be using a real-time dataset of people of Pakistan, create groups of features and train them separately on classification algorithms to find optimal features, create a binary classifier which outputs the risk level of the person being diabetic or not. Finally, create a web application which end user will use as a prediction system. After data collection, we will move on to pre-processing data, in which we apply data wrangling and feature scaling. In data wrangling, we clean the data, dealing with null values and transforming it into numerics so it will be useful in the classification algorithm. Feature scaling simply is to transform all values in the dataset into a specific range 0 to 1 for efficient processing. Then after pre-processing, we will apply feature selection. Feature selection, in simple words, is to create subgroups of our features from the dataset. The reason for feature selection is that we may not know which features are contributing the most in our predictor and which are most useful for our algorithm. Then, once we have all the subsets of features, we will train and test each group on classification algorithms. We will evaluate the results then, more on that in a bit. Finally, we will use the optimal features with the best algorithm in our predictor system. We'd like to tell you about the dataset. This is a real-time dataset. We collected the data from lumps and through online surveys. It has 433 attributes, entries, or as we can say, with 10 features. Moving on to project demonstration. So here it is, Pakistan's first ever pre-diabetic prediction system. We have proudly written it. This is how our homepage looks like. We have also explained the main working for our users. We have also given some information about its origin, from where we got the data, what we did with it, what are our main steps, and how we are evaluating. We have a page for the test where the user can have their test by giving in some inputs. We'd see that in a bit. There is a statistics page as well, which gives us more information about the situation in Pakistan. We also have our team here just in case people need to know who are the people behind the screens. And finally, we have assured our users by telling them about our predictor system's accuracy. So let's try to test it. Here are the user inputs. The user will give in few inputs based on which our predictor system will evaluate pre-diabetic state and what would be the risk level. The user inputs are fairly simple, so we'll try to test it. In case the user misses any, let's say, an input level, it also highlights which required field are they missing. So let's test it. Based on my user inputs, the algorithm that will be used will be support vector machine. and that will output the possibility of the risk level that I may be diabetic or not. So here is the output page. We have a risk meter as well as the level, which highlights the severity of the risk based on user inputs, and we have certain tips based on our output. We have some suggestions as well. Now all this happens based on user inputs, and then the machine learning algorithm takes it in and outputs from the predictor system. So we'll test it again. This time it says we have a low risk of diabetes. And one last time. So this was it. This is the predictor system's front end, which makes use of machine learning algorithms with optimal feature selection. Coming back to the presentation, the timeline is interesting in terms of data collection. It was one of the most challenging parts of our project. It took almost 3 months. It also is very important. As Andrew Ng said, it's not who has the best algorithm that wins, it's who has the most data. Now coming to results. Optimal features we got were 5 out of the 9 we had. We created 8 subgroups of features and we trained and tested them separately on all 3 algorithms: naive Bayes, random forest, and support vector machine. The optimal features included gender, age, family history, lifestyle, smoke, and glucose level. These are the features that we ended up choosing in our predictor system because these were the ones that gave the optimal results. The best algorithm out of 3 was support vector machine. We can see that from the algorithm result report. Support vector machine is by far the best algorithm for this problem. We used Python's libraries sklearn for machine learning, feature selection, and result evaluation. Pandas and NumPy for data analysis, data wrangling, and data transformation. We used the Flask framework for web development using Python. We made use of Jinja templating language, which allowed us to use variables in HTML and CSS. For collaboration, we used GitHub, and Jupyter Notebook was used for data analysis and data cleaning. We believe this application will play a vital role in creating awareness among citizens about their guilty pleasures of consuming sugar. After knowing the possibility, people will be more careful about the sugar consumption. We are trying to create a step towards a diabetic-free Pakistan. This is it. Thank you so much for watching and listening. It means a lot. Hope you enjoyed, and we hope we did justice to our brilliant project by presenting it well. Thank you so much. Signing off.